So welcome to today's collaborative webinar. The title, AI-Driven Network Automation for Traffic and Service Resilience, Phase 2. This was a catalyst that was prepared for the TM Forum just some weeks back, very recently. And we saw that there was so much resonance and it was such an exciting story that it was something we really wanted to share. See here some images of in Copenhagen in Denmark just a couple weeks back of the team really across the globe, a cross-national team of different collaborators for the project, really bringing in their own expertise, their own background, their own specialties, and really an exciting event and opportunity, not only to network, but to bring together these skill sets in order to find solutions to increasingly complex problems and really to look at how AI, machine learning can also be employed in order to find innovative solutions. And I will say very quickly, looking at network resilience, I have to share a personal story very quickly because in April of this year, I was in southern Spain. I happened to be there for the network outage. And it was really something to experience and see firsthand what the world was like before we had constant connectivity, to see everybody a little bit panicking, not knowing if it was some sort of cyber attack, why nobody could connect, seeing everybody, face to face, coming outside and trying to figure out what was going on, sharing the rumors and information that they were hearing, but really not having that ability to connect to a wider, internet intelligence or this access to so much information that we sort of take for granted daily. I have to say, on the one hand, it was kind of nice. It reminded me of my childhood since I am pretty old now and, of what it was like when we didn't have that constant connectivity. But obviously, there are a lot of drawbacks to that as well and a lot of dangers, really. And obviously, as well, financial loss. So looking at, this, and I'll introduce everybody, but looking at pooling these resources and presenters from across the globe, I think the idea really is, looking at trying to achieve some sort of, in English we say that sometimes the sum of the parts is, that the whole is greater than the sum of its parts. And that really is, I think, what these catalysts offer is that opportunity to bring together people and really look at complex problems from different angles and bring in intelligence and innovation from different angles. So today, myself, I'll just be moderating. I'll be the guide on the side for a bit. My name's David Tomasz, and I'm the Director of Marketing at Infosim. We also have Delphi Gennardi, who is Manager of Connectivity and Internet-Based Platform at Telen, and also the lead of this Catalyst project. Andres Polz, Chief Evangelist from Beyond Now, co-chair of the API program at TM Forum, Distinguished Fellow of TM Forum since 2017. David Huck, who is a Director of Research here at Infosim. He's the technical lead of the Catalyst, coordinating implementation, integration of assets from all 14 partners that have contributed. And then Maria Goretti de Cubo, MTN Senior Manager and Transport Performance. I think, Maria, this is your first personal participation. I know you weren't able to make it to Copenhagen, but has been very active and is really looking at specific use cases and employing what's been developed here in terms of research and in terms of bringing that to concrete use cases. And I think with that, Delphi, I can hand it off to you to begin the presentation.
Yes, thank you, David. So hi everyone. My name is Delphi. I'm from Tallinn. So welcome to our Catalyst project. So before I start, first thing first, let's take a look at the background and also the problem statement that become the foundation of this project. Why at the first place we want to make this project. coming forwards. So the first one is that let's take a look at what we are facing today, especially from the point of view of us in the champions side, in the CSP side. So we see that oftentimes we talk a lot about how us as the champions are trying to give the connectivity service to our customers, how sometimes we're actually saying to them that we put a certain SLA to make sure the network's availability and also connectivity, and also trying to say to them that there would be like no availability issue. But at the matter of fact that we are facing today, fiber cuts is still happen around the globe. So just recently, like I think David has shared his personal experience related to the Spain problems, how everyone's very anxious about the things that happens in Spain. Fiber cuts happened in Spain very recently, and also the national outages happens in Canada, and also just last year, more than 100 subsea and also fiber cuts happen globally each year, and the numbers is not kidding. So despite those numbers, let's take a look at the reality that we are facing, especially us in the operations and also from the CSP's point of view. We are still very manual and also reactive, which is causing the delays in our fault detections and also how we diagnose the problems, not to mention to repair the problems. So at the end of the day, it's going to compromise the customer trust and also increase the cost. What this really means for us in the CSP side, the first one is that we think that the customer experience is going to be suffered, and also our operational cost is going to be climbed. But then with that high number of costs, we are still very struggling to maintain the mean time to repair as well. So in shorts, we are saying that the networks today are overbuilt, but then it's become very underused. And it's very hard for the network to adjust on their own. So this is the problem statement that we are trying to impose in here. And then that's where our catalyst comes in. So our catalyst is actually brings to life a next gen framework with the combination of the different standard. We talk a lot about the camera API, the map, and also the 3GPP. And all these standard APIs are going to be powered by the ODA and also the TM Forum assets. With this combination, we are trying to create a self-aware adaptive platform that enables an intent-based connectivity as a service using the B2B2X model. So this is not just an innovation, but we're actually trying to reinvent the network itself. So in this phase two, we are extending the number of the champions, and also we are extending a great numbers of the technology partners. Not only that, we are also trying to involve the research institute from the university to validate the different aspects in this project, especially with the energy saving part. So let's take a look at the challenges that we are trying to tackle in this catalyst. There are four bold missions that we are trying to address in here, which is actually to revolutionize the network itself. So the first thing first is that we think that the approach to the outages is still very reactive. We feel like the networks today are still like a firefighters where we only jump into the fire when we see that there is a fire, right? So this is actually the things that we are trying to address, because when we see the cable cuts, we're actually seeing the network down first, and then we're trying to find the root cause. And oh, okay, it's because of the cable cuts. So all the CSPs right now are very struggling to find out what would happen before it happened. So that's the problem. And also the second one, we think that it's very limited in terms of the network automations. We feel like the current systems cannot automate the big picture of the business intent into the network execution. Oftentimes, we feel like the network is actually cannot be controlled and also managed. So the third one, we also see that the complex scales of the networks, it's actually something that we cannot prevent. The network has the multiple systems, but then the manual steps and also a lot of confusion. So what we're trying in this project is that we're trying to simplify and also automating these chaos to actually make sure that the networks can be more flexible, then also making sure that it's going to be very easy to manage. And last but not least, it's actually the energy saving. We think that the network is actually wasting a tons of energy because the network needs to be always on even when it's actually not needed. So what we're trying in this project is that we're trying to validate the different aspects on how that our project is actually going to impact to be using for the smarter resource use, meaning that we are actually going to save the planet and also cutting the cost. So in short, what we are trying to do in this project is that we want to make the network that can predict, that can fix themselves, and also run smoothly. So yeah, over to you, Andreas, for the next slides.
Okay, thank you, Delphi, and thank you for your leadership throughout the Catalyst. So I'll be talking a bit about the scope and also including the history and outlook of our Catalyst here. The Catalyst really is across many domains. It's also across many continents. It's actually 6 continents when we look at all the assets that we involved in these Catalyst, because we even had the submarine cables from Tallinn as well as Seacom in our scope. And very many technologies applied to move forward in these, bringing us to AN level 4 and 5. Intent-based digital twins, the open APIs, the analysis, the orchestration, real-time dashboards, and looking at the energy optimization of it all. And it brings these self-everything and zero-everything automation across all of those domains. We started last year in phase 1, where we basically developed the reference architecture and implemented the first intent-based orchestration and connected and geared it up for the connectivity as a service deliverable for TM Forum. This year in phase 2, we refined that and moved from the architecture to a total realization of the key processes in this, based on doing that for the networks. The plan for phase 3 moving forward is to go on from doing this for the networks to also do this for the cloud native based environment around it, because the realization is that today IT and network are codependent. The network does not exist without the IT and the cloud, and IT and the cloud does not work and deliver without the network. So both need to be in scope. If we look forward to the next slide, with the solution architecture that we developed and deployed in this catalyst, in 2 minutes, I can't explain all the details. So if you're interested, follow the links provided through this webinar and look up the details in our documentation for the catalyst. I will just pick out the one key difference to other catalysts that we saw this year with about autonomous networks. This is the one that included the view of the party and core commerce domain in TM Forum, including the ODA components that play in this one, because the position in our catalyst from the service providers and the participants is you cannot allow the AI driving the autonomous network operation to just act based on the network information alone. If the AI based on intents in the network changes the network as it thinks it's fit for the network, but does not have learned information from the customer, the inventory and the product catalog domains, it may make decisions that counteract any commercial sensibility. It may throw costly changes at a problem that actually does have very little impact on the bottom line of the involved players. So we did this also on this service order, product order. We did a very first implementation in TM Forum in this architecture of putting the intent not only on the resource layer and in the network, but also in the product order, service order, to show that the TM Forum open APIs can include intent as a payload on the commercial interaction as well, and then use that to drive interaction with Camara APIs towards provisioning a network slice in the mobile network. As I said, more detail in our documents that you can access via the links. In an outlook of how this is flowing back improvements into TM Forum, there's the information on this slide. As you all know, TM Forum is a member-led organization where the main value lies in the standards provided by TM Forum. So taking our learnings from the Catalyst is a main part that we are doing just now. And there it goes across many of TM Forum's programs and standards. We are contributing a lot back into the digital ecosystem management on the commerce layer, use cases on intent, conflict, and resolution in GB 1035C, a lot into the core of the open digital architecture, proposing missing B2B2X and communication as a service business processes, mostly into IG 1228 and TR 302, and then a lot of contributions. I'm not going to read the full list here, but the first and key one is probably the one done from the contribution from Orange in these Catalyst with the autonomous networks use cases from Orange that went into IG 1218G. And of course, also very important for me in my role as co-chair of the Open API program in TM Forum, the tests we did on TMF 921 as APIs focused on the extensions for intent, but also intent extraction and decomposition that contribute with output from the DEM project, and also into the operate APIs in the suite in TMF 931 and the GSMA Camara APIs that is even shared beyond TM Forum in SDO collaboration that extends to JSMA, ETSI, and MEF. Thank you. I think that's over to David.
Yes, so I will take over here. Thank you, Andreas and Delphi. It's a pleasure for me now to talk about technical integration in a bit more detail, showing what we actually did there, how the implementation looks like. And to that end, I'm first starting here with a slide showing an overview on how this is technically integrated. We are very happy. It was a lot of work in the last few months, a lot of things to organize, to discuss, to plan, and then to implement. But we are very happy that we can say that we have a catalyst where all of the champions and the participants have not just contributed with some slide work or with use cases on whiteboards, but they have actually offered data, offered components, offered things to integrate. So this kept us busy to do all that. but at the end of the day, we are really happy that we have that. And maybe looking at this picture a bit in more detail, as a very central component, we have two systems from Beyond Now and Infosim, which are basically taking the role of the data lake, where we have a kind of natural separation that Beyond Now is more taking care of the commerce and customer-facing layer, and StableNet Infosim is more taking care of the resource-facing layer, if I may call it this way. And that way we can make sure that we have a central place in our architecture where we have the data available, which is a central place to go to, also for all the different applications and components to connect to and to automate from there on. So just quickly going through some of these points here. We have topology and power data, which was mainly coming from Infosim and the University of Würzburg, based on different research activities and research projects, where we have also generated different worldwide topologies based on realistic data. We have had a chance to use this also to generate new data and to prove this in the project. Then we have from CCOM and Tallinn, we got undersea cable data and all the connections between the different countries, which helped us to look at the undersea cable scenarios. Orange was offering IP and optical data, which is basically part of an optical network with an IP network on top. And Changhua Telecom was adding to this also the view from optical data and some predictive maintenance engine, which is mentioned up here, where they are basically able, based on different KPIs, to forecast potential problems coming up. Then we had Verizon and Shabody bringing in the industrial IoT part of things and some factory data. We had radio link data as well from MTN and DGS, which was serving for some of the use cases. And then there is also the link to the fulfillment scenario, where we had connections to Beyond Now and another partner who was finally not officially joining, but Ubicube, maybe also known to some of you from previous catalysts we did. They were also participating in the automation in the backend without being officially mentioned. And last but not least, we had also some link to previous work that has been done with Telecom Italia and Chalmers in Sweden, where we were working on optical data as a base for detecting optical attacks. And all of this data was being put into the data lake using various APIs and served as a base for the further components. So we had an anomaly detection and cluster analysis thing, which was mainly based on the previous work of MTN and Infosim together in the StableNet Innovation Lab, where we were looking into different ways for time series analysis. And luckily, we could, together with MTN and Infosim, we could also define a data set, which is not the real data anymore from the customer, but which is close to the real data, so we can still showcase these things and have something to work with. Then, as I mentioned, from Changhua Telecom, they have an engine for predicting errors before they actually happen, in order to be able to react in the network before the customer is being impacted. On the power and sustainability side, the University of Würzburg and Infosim in another research project are working closely together to do analysis of power usage in different scenarios, where the power is going, where is it needed, how to potentially take into account critical infrastructure situations. So if you, for instance, have power outages in some places, how you can how you can focus the energy to these places where it's most needed. Then I had already mentioned the optical attack detection. And last but not least, from NTT, we have actually two components. We have on the one side an LLM agent for self-recovery, which is basically an LLM that is assisting people to recover problems in the network. I will show this in the demo in a moment, in the implementation. And the second thing is also an intent interpreter, which is helping to get in contact with the customer to, for instance, do some upsell if more bandwidth is needed on a short note. Then we have also the digital twin and network simulation component from Orange. And last but not least, we have in the reconfiguration and provisioning part, we have again Shabody, as mentioned before, and Ubicube in the backend. And with that, I'm now switching for a few minutes to a short live demo. To that end, I'm here opening a StableNet system, where I'm basically showing parts of the implementation as we had it also for Copenhagen. And this is an interactive weather map. So I will have different tooltips when hovering over this, which is basically showing some of the underlying things part of the implementation. And we have here in this weather map, we have a world map, as you can see, with different locations and different things spread across the globe, highlighting again the strong collaboration we had globally. And I want to mainly focus in the next, let's say, 5-6 minutes to come. I want to focus mainly on two main scenarios that we had, the service fulfillment scenario and the assurance scenario. And I will quickly run you through this by opening different tooltips and showing how the systems are interacting in the implementation. So to that end, let's first focus here on the service fulfillment. And let's imagine that we actually have two factory locations, in this case in Northern America. We have one in Santa Monica and one in Las Vegas. And now the factory in Las Vegas has a problem, and the people sitting in Santa Monica need to do some remote maintenance. So they need to actually get a good connection to a stable connection to Las Vegas to fix the issues. And normally they have 200 megabits as a downlink bandwidth they are paying for, but for the maintenance they actually need more, and they get this really quickly. They can't wait like weeks for this to be organized, but there is a quick upsell is needed. And now let's look at a few things here. So first of all, we are looking here at this chart. You can see here several things, the downlink and the uplink. We will focus here on the downlink from Santa Monica to Las Vegas. So what the people in Santa Monica are downloading basically from Las Vegas. And you can, to that end, you can see two curves, the green one and the yellow one. And if you look at the green curve first, you see the green line, you actually see that normally the speed we are assuming here in this scenario that the people in Santa Monica regularly use is around 100 megabit. But when they are doing the remote maintenance, they would need roughly something at least in the area of 200 megabits. And if we are now putting this in relation to what they are currently paying for, as I mentioned, they are paying just for 200 megabits downlink, then we have the yellow line with the scale here on the right. And you can see that normally they are using about 50% of their bandwidth. And now when they start using almost 100 Mbit, they hit like the top level of almost 100% of what they pay for. And this might not be enough actually for doing their use case. And this is now the first part where we have an AI-based scenario coming into play. With the intent interpreter from Entity, it is actually possible to have a chatbot between the customer and the system to get into discussion and to request additional bandwidth, to discuss by when is this needed, for how long is this needed, what precisely is needed. And you can here just see a quick indication in this short video here that this discussion is going on. And as a next step, this is actually then triggering directly the loop to the BSS system. As Andreas mentioned, this is always involved in our case. And we can here see a short video from the BSS system. And what you can see here actually is now we are deep diving into one of the factories, and we are not actually seeing the change happening live, but what we are seeing is that the change has been implemented. So in a moment here, when the drill down is finished, you will see the different offers and the different activities that have happened. And in a moment, you will actually see a number 200 and a number 400, and that this change has actually taken place. So this is an automation triggered here, and this is not needing many days or weeks, but this can be done in very short time based on the automation. Then this was just the order part. So this was just the part making sure that the customer is actually charged for this, and this is actually doable. And now we have to technically implement it. And to that end, we see here the solution from Shabody with a view on the invocation statistics and the intents that have been changed here, like the intent management. And this is actually just an indication that in the backend there are some logs which indicate that the change has been taking place. So summarizing this scenario, what happens now, looking again at the curve. 1 second, here we are. So what actually happens is in this moment here, when the yellow line drops to 50%, this means that the customer is still using 200 megabit, but now the bandwidth has been increased to 400, which means that 200 just roughly corresponds to 50% of what it's being paid for. And this suddenly gives the customer the possibility to, for instance, increase the speed to 300 Mbit and to do the remote maintenance in an adequate way. So this is in a nutshell the first scenario. Really quick, the second scenario for service assurance. Here again, we are looking at 2 factories, and we have some communication data about different things happening between the 2 different factories. And the scenario we are looking at here can actually be best described with this picture. As I had mentioned, the champions were providing us example data corresponding to realistic environments. And what you can actually see here is you have on the lower layer, you have an optical layer. On top of it, you have an IP layer. And on the very top, you have the application layer spanning across this. So the 2 factories are communicating with each other across the IP layer. And the IP layer is actually routed on base of an optical layer underneath. And what we are now looking at is that one of the optical links fails. And before this is actually causing a real feelable impact to the application layer, we already will pull up a backup link on the optical side so that the customer is never impacted. And we can easily repair the original problem without the customer recognizing anything. And I can best explain this with now looking at this tooltip here. So here we are now looking at some optical data that we are measuring. And more specifically, we are actually looking at one of the KPIs that can be measured on optical interfaces. In this case, we are looking at an optical interface from one node in Alicante to another node in Alicante in Spain. And we are looking, the blue line is the primary path and the red line is the backup path. And what you can actually see here is that we are looking at the TX bias, which corresponds to one metric measured in ampere. So it's a current being measured. And if this value is slowly increasing, leaving the normal range, this is an early indicator that something might be happening. And Changhua Telecom with their predictive maintenance engine are actually catching this up front and already triggering some reaction before the customer gets impacted. They can also recognize more complex patterns, but in this case, we have focused on something very simple to explain the story as good as possible. And now let's look at this for a short moment. So what happens? The backup link is switched off, it's not needed. The primary link is running normal state here, and then suddenly we have a slow increase. But this increase is still in the normal range. So you can see it's far from the range where it would actually cause the link to fail and the customer to be impacted. So the critical range is not reached yet. And what now happens actually based on the automation in the backend is this is being recognized early from the predictive maintenance system. And this is triggering the digital twin from Orange. I will show this next. This is triggering here the digital twin, which is actually having a representation of the optical and the IP layer part. And this can be used as a base to do some network optimization. So here you can see a system ThingsNet in from Orange that they brought in as a component where they are building the optical and the IP layer as a digital twin. And they are feeding this into actually this system here, which is the NetSim4Opt, also from Orange. Where you can see on the bottom, again, the optical layer and on the top, the IP layer. And they can use this for running some optimization, calculating some alternative paths to react on the problem. And then we have actually the system from Ubiquube that I had mentioned earlier, which is actually here automating something in the backend and is actually triggering some reaction in order to fix the problems. And now getting back to the picture where we are now. So in the picture, what happens now is the backup link is turned on. So we can shift the customer to the backup link. So there is no impact anymore, or there will never be any impact to the customer because before it's getting critical, the backup link is already there. And now this buys us some time to solve the original issue, because just switching the customer to the backup link doesn't mean that suddenly the primary link is okay again, but it still needs to be fixed and taken care of, either by reconfiguring it, replacing the device, replacing parts of the device. So this is where the LLM agent from NTT comes into play. And here we can see just a short video from the implementation that NTT brought into the Catalyst as well. And this is basically a combination of logical charts built based on the topology, combined with configuration data pulled from the topology, combined with manuals, user manuals from the devices. And this can then be used to instruct the customers either to just reconfigure the device or to reset something, or also to help them with setting up a new device after replacement. And this leads us to the last part of this chart, which is basically the blue curve here going completely down to 0, which is either indicating a switch off and restart, or it's indicating switching off and replacing by some similar device. And this ends the story here of the service assurance part. So first mitigating the issue without customer impact, and then taking care of the original problem. And for the sake of time, I will not dive much deeper into the other use cases we have looked at, but we have also just quickly mentioning it. As I said, we have also done some energy analysis here, looking into energy usage and the carbon footprint based on different power plants and so on in different countries. We have also done anomaly detection and traffic forecasting and some work on this. And last but not least, there is also still this subsea cable part here. You can, for instance, see from the Tallinn side an example of a subsea cable with the different locations. But for the sake of time, I will not go into more details here. And I want to close my part before handing back to the presentation, just with jumping to a website here, which is actually this here. If you haven't been there before, or if you want to go there again, please have a look at this page, which is the AI-driven network automation for traffic and service resilience phase 2 catalyst page. All of the catalysts shown at the show have this kind of website. And in our case, we have really put a lot of effort to put here a comprehensive list of all the resources we have with a glossary, so that you can easily find what you search for. You will have PDF documents, pictures to download, some videos to look at, some additional information. You will also have, if you are specifically interested in any of the solutions used by one of the partners in the backend, you are also able to find this here. So I think it's really worthwhile. We had also a publication in a magazine. So with this enough advertisement, I'm just copy pasting the link here and switching back to the slides, and I will then in a moment copy paste the link as well to the chat. And with that, I'm handing over to Maria. Thank you.
Thank you very much, David. Thank you, Delphi. Thank you for the wonderful show in Denmark. So we come to the business outcomes. Basically, we have grouped these business outcomes into 4 different pillars, and I will start with how it comes to us, the customer, then the society, then the CSPs or the operators, and then the industry at large. So first, I start with the customer. Of course, for we customer, we are looking at sustained, consistent performance, and this catalyst will enable us have consistent performance for anything we are doing: internet, gaming, OTTs, whatever it is we are doing, is going to help us with consistent quality of service. And it simply means that we are going to reduce SLA violations by 20. And at the same time, we are going to increase our net promoter score, okay? So basically, for customer, it's all wins for us as a customer and for you and me. Now, let's look at how it impacts our society. So if we are looking at the society at large, if me, the customer, is happy and I have consistent quality of service, of course, it's going to drive first and foremost, enhance. It's going to enhance reliable services like my education, online education, emergency services, name it all. Everything we do online is going to enhance the reliability of those things. And then second, it's going to help us reduce carbon footprint. Of course, we already know what is happening, the climate warming and all those things. If we can have reliable service, it simply means we are going to have less and less issues with carbon print. And then we equally have easy allocation of resources, dynamic resource allocation. For example, today I'm gaming, tomorrow I might be just chilling with my Netflix or something else. But the idea of this is we can dimension resources as the customer needs, and we can easily have reliable service based on any services we are looking at. And finally, we are looking at how this has enhanced telecom infrastructure. If we have consistent quality of service as a customer, it's going to drive innovation, it's going to drive business growth, and it's going to help us create jobs in the society as well. In turn, all this is all win-win for the society. And then we come to the operator, the CSPs. Come on, it's all wins for us here. We have 80% enhanced traffic and service resilience, 50% reduced OPEX, 60% improved go-to-market, and 30% cost savings due to AI automations. And as you already heard David talk about the LLMs and the digital twin, is all about wins and the best way to make automations work for the CSP or the operator. And finally, the industry. Of course, we already know that based on what Andrea shared and Delphi shared as well, you see that it's all about using standard APIs, and that will enhance enhance the ease of integration to multi-vendor platforms. And at the same time, we are looking at setting a foundation towards a future autonomous network. Of course, if you remember, this phase 2 is all about architecture implementation, and this is the foundation for autonomous networks. And then we are looking at cars, connectivity as a service. Okay, it's going to unlock this potential as industry potential for connectivity as a service. And finally, we are looking at B2B TX, 2X partnership. Of course, if B2B is happy, their partners as well, it will open doors for various parties to interconnect with B2Bs. So on that note, let's look at, with all these business outcomes, we take a look at the next slide and what we have for you for the next phase. And that is phase 3. So what are we looking at? In conclusion, I want you to understand, I want you to know that we had a very wonderful team. We had 14 different industry leading companies join this catalyst. As you can see, you can see our faces. Well, it might be too tiny, but I can just name a few. You already met David. You have already met Andrea. You have met Delphi. And there's so many others too, from Shabodi, Telans, and so many other people that made this catalyst happen. However, we are still looking at the next actions. We are still looking for very, very talented, like-minded partners to journey with us in this third stage, because this stage promises to be full of innovation. For example, we are looking at the cloud natives. We're looking at the Kubernetes based architecture. And of course, you already know that cloud native deployment is going to enable CSPs, hyperscalers, operators, enterprises to scale both horizontally and vertical. So, and we are equally looking at contributing new things to the TM asset enhancement. Of course, we know that innovation is an everyday thing. It never stops. It keeps moving. And on that note, I would like to let you know, please, if you are interested, please join this wonderful project, because we intend to take this project to the next level and ensure that it's all win-win for both you, the customer, you, the society, the operator, and then of course the industry. Thank you very much, and I hand over to David, and as we wait for more questions on this. Thank you.
All right, thanks so much, Maria. I think with that, let me just have a quick last word, and then we'll stop the recording and we'll have an open Q&A. I think, starting out and talking about, one specific use case, whether it's, network outages and the wider impact of what that can mean, it's so much more. It's so much more looking at how automation can really support not just improvement, but really just trying to find to strike the perfect balance of how to create resilient networks and provide services that are robust. So whether it's looking at sustainability, which is something that I think is a concern, is important, and has value across the board in optimizing operations. So sustainability, root cause, when there's an issue, knowing where it's coming from in a simple way, in a meaningful way, and being able to not only find it, but to find a resolution as quickly as possible, to reduce mean time to resolution. MTTR, of course, is important, and go-to-market times. And then finally, of course, resource management and cost reduction, resource reduction. So yeah, the story is wide, the applications are wide, and we hope that if you are interested in seeing how this might contribute to real world applications for you, for your companies, that you reach out, let us know. We would be very happy to provide more information. We already gave a link in the chat for the catalyst itself. And I think with that, I just want to thank our presenters. So thank you everybody for presenting, for sharing the information, and really lighting that fire to show what is possible with this collaboration and with the synergistic effect of bringing brilliant minds together, if I'm honest, across the globe. And I think that's the value of these catalyst projects with TM Forum. And of course, to thank you, everybody who's been here, who's taken the time out of your busy schedules. So thank you, everybody.